So essentially what you have here is the basics of SOHCAHTOA. So sine is going to be opposite over hypotenuse, cosine is going to be adjacent over hypotenuse, and tangent is going to be opposite over adjacent. And then you have the inverses of the sine, cosine, and tangent functions, which are going to be the inverse of sine is cosecant, the inverse of cosine is secant, and the inverse of tangent is cotangent. So next, this is the basic unit circle that you're going to want to use to solve trig equations. It goes from 0 to 2 pi, and basically you're just going to want to know these. And this can be a very common mistake, is mixing up the sine, cosine, and tangent values of these different angles when solving equations. So the unit circle is going to be solved using special right triangles, and these are going to be the 45-degree triangles and the 30, 60, 90-degree triangles. So basically you're going to orient these to wherever you are on the unit circle, making sure to consider negatives when on that circle in order to solve equations. So here we're going to do some quick problems. As you can see here, sine of pi over 6 is going to be 1/2. Cosine of pi over 4 is going to be root 2 over 2. Tangent of 7 pi over 6 is going to be negative 1/2 over negative root 3 over 2, which is just going to be root 3 over 3. And then we have sine of 5 pi over 3, which as you can see here is going to be negative root 3 over 2. Cosine of 4 pi over 3, which is just going to be this negative 1/2 value, and tangent of 7 pi over 4, which is going to be a negative root 2 over 2 over a positive root 2 over 2, which is going to be negative 1. So to graph sine of x, you're going to use the unit circle for your points, but more basically, it's always going to start at the origin unless there's a horizontal shift. And the most basic sine of x is going to have a period of 2 pi, which means it's going to repeat its pattern every 2 pi. So the graph of cosine of x is essentially sine over x with a pi over 2 shift. It's going to be the same basic unit circle construction, and just like sine, it's going to have a period of 2 pi, which means it's going to repeat itself every 2 pi. So the graph of tangent is a little bit different. To start here, the period is pi and not 2 pi like in sine and cosine, which can be a common mistake. Tangent starts at the origin like sine, and essentially it has a period of pi, and to start this, you're going to go over to the right pi over 2 and over to the left pi over 2 to start that period of pi, and then those asymptotes that you've put there are going to repeat themselves every pi period, and then you're going to create a function that sort of looks like y equals x cubed. So you're going to go up 1 and over 1 and down 1 and over 1 from each of those points in the center of your period, and you're going to follow the asymptotes with your lines going out. So here we're going to graph with some modifications to sine. The first thing I'm going to do is graph the original sine function, which is just y equals sine x, just to have a basis for where I'm going to put the changes to the graph. Next, I'm going to focus on a change in the period. So in this case, that period change is going to be the 2x, which means I'm going to divide 2 pi by 2 in order to get the new period, which in this case is going to be pi, and regraph my function here in pink with the period of pi. Next, I'm going to focus on a midline shift of 3. This essentially means that your function is going to shift up 3 units. So my new midline is going to be at 3, and originally it was at 0. Next, I'm going to focus on an amplitude, which is going to be before that 2 multiplied before your sine function. And here, I'm just going to bring all my points up 1 because my original difference between the midline and the points was 1, and I've multiplied that by 2. So now that difference is 2 instead of 1. Now there's a horizontal shift here, and the period also needs to be taken into consideration for this one, which you need to do pi over 2 divided by 2, which is pi over 4, and that's going to shift right pi over 4 because it's a minus pi over 2. So now on to the cosecant and secant functions. Here I've just graphed secant because they are very similar. Secant is going to be based off the graph of cosine. So essentially here I have graph cosine in the black, and then there's going to be asymptotes wherever that graph hits 0, and then there's going to be sort of a parabola that follows those asymptotes at all the hills and valleys of the cosine graph. And this is going to be essentially the exact same thing to the cosecant graph with just sine as a base. So for cotangent of x, essentially this is just going to be look like the opposite of tangent of x. So you're just going to graph your same what looks like a y equals x cubed function, except just following the asymptotes in the different directions from tangent, as you can see here. Moving on to solving trig functions. First, here's a basic one. Essentially, it's going to be solving like for x, which in this case, I'm going to solve for cosine of x. So I get that all the way down to cosine x equals 1/2. And then using my unit circle I have here, I'm just going to find the places where cosine x equals 1/2, which would be at pi over 3 and 5 pi over 3. And a big mistake with these is that you have to add 2 pi n if it doesn't specify that it's specifically from 0 to 2 pi, because this includes all answers that are outside of this unit circle. Next, we're going to solve this one, which is slightly more complicated. First, I'm going to turn tangent x into sine x over cosine x. I'm going to transfer that onto the other side, so this equals 0. Take out a sine x, and then break this apart into two different things that equal 0. So I can find my singular x's, which are going to be 0 plus 2 pi n, pi plus 2 pi n, 0 and 0 plus 2 pi n again, so essentially it's just going to be 0 plus 2 pi n and pi plus 2 pi n. In order to solve more complicated trig functions, you're also going to want to memorize these double angle formulas and half angle formulas in order to solve. Next, one that uses my double angle formula for sine, so I'm going to turn the sine 2x into a 2 sine x cosine x. Going to bring this cosine x over, factor out a cosine x, and again split these to find my x's. So in this case, x is going to equal pi over 2 plus 2 pi n, and 3 pi over 2 plus 2 pi n, and pi over 6 plus 2 pi n, and 5 pi over 6 plus 2 pi n. Next, we move on to this one. So essentially, I'm going to plug in for cosine equals 2x, my double angle formula. So it's going to be 2 cosine squared x minus 1. I've chosen in this case to match the problem. Then I'm going to subtract 3 cosine x over and factor this just like you would a polynomial. And in that way, I'm going to find two different things which I can set equal to 0 to find x. And in this case, I'm going to get pi over 3 plus 2 pi n, 5 pi over 3 plus 2 pi n, and 0 plus 2 pi n as my answers.